Hello students, we'll start with a new topic today, that is stacks. We have already seen in the previous units, we have just seen the overview of the definition of a stack and what are the operations that we can perform on the stack. Let's once again revise this. So stack is a data structure where elements can be inserted or deleted only from one end, called as top of the stack. So you can imagine a jar or a bucket wherein one end of the jar or the bucket is sealed and only one end is open. So whenever we want to place any items inside the jar or the bucket, we can do it from the end which is open. And if you want to delete the items, we will also be again allowed, or we are able to only delete those elements from the open end of that jar or the bucket. So likewise in data structure, the stack works on this concept. That is, we are allowed to insert or delete elements only from one end, which is called as top of the stack. So stack works on the principle of LIFO, that is last in, first out. What is LIFO? Like for example, say that I have these three elements that I want to place inside my stack. So I am going to say that, assume that I have placed these three items here. So LIFO means last in, first out. The last element that we placed in the stack was 30. So 30 is going to be the first item to come out. So that is last in, first out. The last element or the item that we pushed inside the stack is going to be the first item to pop out or to be deleted. So we have two primitive operations that we can perform on the stack, that is push and pop. Push indicates that we are trying to insert an element or add an element inside the stack, and pop means we are trying to delete or we are trying to remove an element from the stack. So first let's have a look at the push operation. Now say that for the first time I wanted to insert the element 10. So I have inserted 10. So the operation that I performed when inserting the element 10 was push. So pushed the element 10 into the stack. Now whenever we want to push an element or insert an element in the stack, we first need to check whether our stack is empty. If the stack is full, it means we cannot insert new elements. So only if the stack is empty, we will be able to insert new elements in our stack. So say that we have a variable called as top. So top is going to act like, say that it is just going to act like a pointer which is going to be pointing to this current location, or will point to the index of the stack. So as and how we go on adding the elements inside our stack, the value of top needs to be incremented. Like for example, when I inserted the element 10 in my stack, the value of the top now needs to be incremented by 1. So it is going to move here. So when it moves here, now you can see that it is currently pointing to this empty cell. So now if I decide to insert another element, like if I decide now to push the element 20 inside my stack, 20 is going to be inserted at this location where this top variable is pointing. So 20 will be inserted here. So you can say that whenever we want to insert an element, our first thing is we need to check whether the stack is full. If the stack is full, we are just going to display the message to the user that no new elements can be accommodated. Suppose the stack is empty. Let's assume the stack is empty. Then what are we going to do in the next step? Once the element is inserted, we are going to increment our top variable by 1. Just like in this previous case. Just like in this previous case, like for example, let us once again repeat the operation. Suppose now I have inserted or pushed the element 20, and now the next step is going to be to increment this variable top. Increment the variable top here, so that we will again be able to insert the new element in our stack. So now when I insert 30, it will be at this location where this top is pointing to. So let me just repeat once again. When we talk about stacks, we have two primitive operations, that is push and pop. So push means we are trying to insert element inside the stack. So first we need to check if our stack is full. If the stack is full, we'll display the message we cannot insert any items. So if the stack is empty, then we will be able to insert the elements, right? So say that, assume for the first time we have entered the element 10. So once the element is entered, we need to increment the variable top by 1. Then we can insert the next, that is the next element, that is 20. So you can see that if I decide, like if I want to access this variable 20, how can I access it? I will be able to access it just by looking at where this top variable is pointing to. So currently my top variable is pointing at this particular cell or this location which is holding the variable 20. So if I want to access this variable 20, I can just access it with the help of this stack of top is equal to the item. So the item that is placed at the top of the stack currently is the item 20. So if I want to push another element, if I want to push the element 30 here, then you know that when we increment this top variable, the updated location is going to be at this cell. So now if I want to access the last item that I have inserted is going to be stack at the location, the stack of top is going to be the element 30. So this is about the push operation. The next thing that we have is the pop operation. The pop operation basically helps us to delete or remove an item from the top of the stack. So we need to remember that when we talk about stacks, it works on the LIFO principle, that is last in, first out. The last element that I inserted was the element 30. So if I execute the pop operation, the item that is going to come out is going to be the element 30. If I execute the pop operation allows us to delete or remove an element from the stack. So once the pop operation is executed, the item to come out from the stack is going to be 30. So 30 is going to come out from the stack. Just like when we incremented the top variable for the push operation, when we talk about, for the push operation, when we talk about the pop operation, we need to decrement the top variable by 1. So we are going to decrement this. Now you can see that if I want to access or if I want to delete, say that I want to delete the next item in my stack, that is 20. So now top variable is pointing to this location. And now if I execute again the pop operation, the item to be deleted is going to be 20. So once this is deleted, again we need to decrement the top variable by 1 and it will be here. So if I again execute my pop operation, the item to be deleted or removed is going to be the element 10. So let's have a look at the algorithm for the pop operation. So you can see here, firstly, when we talk about the pop operation, we also need to make sure that our stack is not empty. If you have a look now, if there are no elements, we never performed any insert operation or we never performed the push operation, our stack is going to be empty. Just now when we have deleted everything, the stack is empty. So if I again try to perform the pop operation, there are no elements to be deleted. So in such case, the stack is going to be empty, or we can say that the stack underflow condition has occurred. So the first step, it checks if the top is less than 0, meaning here also you can say that the indexes will begin from 0. The top variable is less than 0. Once we have popped the last element, we decrement the top, which means it has come here. So if top is less than 0, as in this case, it means that the stack is empty. So if the stack is empty, we just stop the execution. From step 2 to step 3, we can see that we are just trying to pop the elements. So in step 2, where we say item is equal to stack of top, we are just popping out the item that is placed or that is pointed by this top variable. For example, suppose the top variable is pointing here and say that you have two items that we have pushed 10 and 20. So if you have a look at this second step, item is equal to stack of top. So currently where is the stack of top pointing? It is pointing at this cell. So the item that is going to come out is going to be the item 20. So 20 will come out. So once step 2 is executed, step 3, we are just going to decrement our top variable so that it points to the next available item in the stack. So these are the two operations, important primitive operations that we can perform on the stacks.